Hey, nice here. I often get asked how I do the animations in my videos, so I thought I would go through some of the basics for block entities and just regular block animation. We'll start with some simple stuff and then move on to more advanced applications. I'll talk about the tools that I use and some of the things that I made myself to help speed things up. We're going to use this house to do all of our animation, and the first thing we need to do is get it into a format that we can actually use. And that format is knowing the exact X, Y, and Z position for every single block and its block properties. For a while, I used this Forge mod called Structures to CSV. It's only for 1.19.4, but this is the mod that I used in the OR episode. But now you can do this in Axiom also. If you have a selection, you can export it to a CSV. And a CSV stands for a comma-separated value. You can open them up in Excel, but then we have every single block and its X, Y, and Z position. The downside to this, though, is that we don't have any orientation data, so we just have stairs. And all of the stairs actually have a lot more data with them. They're facing east, they're the bottom half, it's a straight shape. And you need to have all of that data if you're actually going to do anything with animation. And to get all of that data, one of my Discord users, Gamma02, actually wrote a program for me, and it's available to everybody on their GitHub. I have the link down in the description. This file here is what you want to download and use. You'll also need to be able to run Java programs. To use it, first we need to get a vanilla structure file of what we want to animate. We can get that in vanilla with a structure block, or we can use Litematica. To use the structure block, it's in the operator tab. Place it down, select save, and then give it a name. You can go to the opposite corner and set a structure block and set it to corner, and then name it the same thing. Go back down to the first block and click detect, and then make sure everything you want to animate is inside the box, and then hit save. The file will be in your save game folder in the generated subfolder. And then copy that structure file to wherever Gamma's program is at. In Java, there is a size limit to the structure you can save with a vanilla structure block, and that is 48 blocks on a side. So if you have something bigger than that, you can use Litematica. After you have a schematic saved, you can go to the schematics manager, click on the file you would like to convert, export as vanilla structure, click export, and then click Save Schematic, and it will save it as a vanilla format MBT file. With everything installed, you can run Gamma's program, and it will open up this window here. Type the name of the structure file, including the .nbt, process it, it will say done, and you click over to output, and you name it what you want it. I'm just going to name it the same thing, and you have to add the extension. Sometimes air blocks are important to know where they're at, and so you can toggle that off or on. We're going to leave it off for what we're doing, and then we're going to click the output button to generate our CSV. All right, so now we have our CSV with our X, Y, and Z, all of the blocks, as well as all of the properties. So all the orientation for the stairs and everything is preserved. Take this CSV and Control A and copy all of it. Then open up this Google Sheet that I have linked down below. You're gonna click on the A3 cell and Control V, paste everything in there. This Google Sheet does several different things. It works for entities, it works for blocks, it works for animations, it works for different types of animations, and I'm kind of going to go through like all of that stuff. For now, we're going to go with the most simple thing and just using a set block with no timing whatsoever. All right, so back in Minecraft, we can get rid of all this stuff, but something before you get rid of the structure block, take note of this position right here. This is the bottom right corner of the structure, and in our file, it is the origin point. It is the 0, 0, 0. Look at your F3 screen. For us, it's 980, 70, 309. We're going to put that here in the origin. All right, get rid of the structure files. Delete the house. Okay, for the set block with no timing, all we're going to do is drag this all the way down to the bottom. This generates all of our commands for setting every single block in the build with all of its block properties and everything. So we're just going to copy all of that and place it into an MC function file, which is just a text file with a list of commands that data packs use. It has an MC function instead of .txt as the extension. If you don't know how to use a data pack, I'm going to include just a basic template one that you can just drop into your save. So this is the world save for the block tutorial. There's a folder here that I'll have linked in the descriptions. You can just drop this one in and it will work. So in the data packs folder, tutorial, data, tutorial world, and then functions. So all that list of commands that we already copied, we're going to save that into that folder. Everything has to be lowercase, by the way. And then you have to name the extension MC function and save. If you go back to your world, type reload, and then if you type function, we should see that here. And if we run it, bam, the whole thing appears. Well, that's not very exciting. You could do the same thing with a structure file. So let's add some animation to it. So we're still going to be working with blocks, but we're going to be adding some timing to when the blocks actually come and go. And for that, we're going to use this timing column here. And actually, I already have everything set up. Right now, it's basing the timing off of the Y value. So this is going to start at the bottom and start building up. So again, we're just going to drag this entire command all the way down to the bottom, copy all of that, paste it into a new text document, and save it as a function file. I'm going to save it as just timing. And there was one more thing we need to add down at the bottom. And so to do animations, you need to use the scoreboard. And the data pack that I'm providing already, sorry, I just noticed an issue here. Depending on how many blocks you have in your animation, if it's more than what I have here, you might have to drag this column and this column down as well, so that actually works over. So that's why this is missing those numbers. If we would have tried to run it, the function just would not have loaded. Okay, so we need to add this section here for the scoreboard. The data pack that I have included already sets up this scoreboard. It sets up scoreboard with a player called dataman and an objective called count. What this part does here is that if the scoreboard is less than 32, then it adds 1 to the scoreboard. And the next line is that if it's less than 32, it schedules this function to run again, which we need to actually name this the same name as we're naming the function. So the last thing it does, it just basically just resets the count back to 0. And these numbers, 32 and 33, need to be, the 32 needs to be the highest number present that it counts through here. So you might need to change that higher. It looks like 28 might actually be, I can actually look. If you highlight everything in this row, you can see the max is 28. So we can change this to 28, 28, and then this one needs to be 1 higher, 29. All right, if we save all of that, this should run. Reload, timing. Having it show up is a very good sign, because if there's any little syntax error in a function file, it just fails to load and it won't be in this list here. Let me run that one more time, just backed up a bit. So there you go. There is a very simple animation from the bottom up. But for my liking, it's a little bit too fast and it's a little bit too plain because it's just going like layer by layer. So we can control the speed by changing this number here. This is scheduling that function to run 1 tick later. So if we change it to 2 ticks, reload, and rerun, it will run at half speed. And then take care of the issue where it's just like very flat, like layer by layer. Normally what I'll do is I'll take my whatever value I have, and then I'll add a random between 0 and 1 numbers. This will just add like a little bit of randomness. If you shift click down here and then control enter, it will carry everything down through. Copy this whole column back over, override all these commands, save it, reload it, get rid of this again. And so now it should have a little bit more, flavor there. It doesn't look so, procedural. It doesn't look so mechanical, like line by line. It looks a little bit more natural. And you can see that like there's an issue down here when it's loading. It's going to bring up some blocks need other blocks to be there. Like if you have gravity blocks, if you have a gravity block set before the block below it, in this case, there's a vine that's going here that can't sit on this fence, but it can since it's hanging down from there. But this vine isn't loaded yet. So it just pops off the next tick. And so if that's important to you, you can do things like manually go in and like make sure that like some of these other blocks are set like first or something like that. But so you can do all sorts of things with this timing. So just think of this as like a mathematical equation to figure out what order you want blocks to show up in. So we could do it off of the X value here. So just A4. And now if we reload it, it all runs from the right. So here's another example. I want to animate everything based on its distance from this block. So I wrote a function that calculates the distance from that reference block to every other block. So this is basically just the, what is this, Pythagorean's theorem? Yes, it is. We're squaring all of the distances and then calculating the hypotenuse between the two of them, and then I've randomized it from 0 to 2. So if we get rid of the house again, everything goes out from that one spot. Do that again from a different angle. So that's about everything for the actual set block and animating with actual real blocks. But now we're going to start actually using display entities. And so with display entities, you can do things like you can do smooth motion and scale and all sorts of things. First off, we're going to make a tiny house. If you don't know the basics behind display entities, I don't have a video specifically on block displays, but I do have one on text displays, and there are a lot of similarities between the two of them. Hey, future nice here. While editing, I realized that I really should cover some of the basics that we're going to be talking about with block displays. So here you go. First off, this is a display entity. It is just the graphics of the block and not the actual block itself. It has no collision or anything like that. Other blocks can be placed inside it. It does not matter. You can even stack these inside of each other. If you show hitboxes, you can actually see where it is loaded in at. So its origin point is at this bottom corner right here, starting here, and then this ray is going out from it. I'm going to turn on this feature that is in Axiom that gives you this little gizmo, so you can actually do some manipulation of a display entity. Display entities, you can move them in your normal directions. You can do rotation as well, but you can also affect their scale. So let's do 0.5, just make a half size block for X, Y, and Z. And there, now we have a half size block. So you can kind of see it. Oh, the rotation's screwed up. Reset rotation. Okay. So there, we have a half size block. I put it back to 0 there. And besides moving it, there's a thing called translation. So we'll do 1 here. And so we've moved it up here, but where its actual location is here. It's just the graphics are translated to be up there. And there's reasons why you'd want to translate instead of actually moving the block. Those are the main things that we're going to be working with, like inside these spreadsheets for display entities. Actually, that's not correct either. There are 2 other things that we should talk about. If you are going to move this entity, there are 2 different ways that you can do it smoothly. If you are actually going to move the entity itself, like move this point, you are going to be teleporting it. And when you spawn the entity, you can set its teleport duration, and that's how long it will take to move when you teleport it. If you are translating it, then there is a translation duration, and that will affect like how quickly it translates, but not actually moving the entity at all. And you can combine those to do some things as well. Anyway, that's it. Back to exciting spreadsheets. I do have a command here for using no timing, but I think you understand like that. And so we're going to go directly into the timing portion. So I want to make a little platform. We're going to put our house on it right here. And this is going to be our origin block. So 996.69308. We actually want to be on top of that block. So we're going to do this at 70. And then we're going to drag this function all the way down. All right, for entities, you can adjust scale. And so I have a scale right here. And this is 0.625 is 1/16. And then copy and paste that into an MC function file. All right, function ready. And go. Yeah, I like 1/16 scale because then it just lines up perfectly with blocks and everything. So basically one block becomes one chunk. So let's change the scale to 0.125. Copy, paste, save, and reload. There, a little bit bigger. But these are entities, so you can just kind of walk through them too. So that's a bit of a downside when doing some of this. Let's animate these blocks so that they actually move. All right, I've shifted the house over a little bit. So in the translation here, I have it loading in at the origin 0, 0, 0, so it's not moving it left or right or up and down or anything. but I want to make this full size in the location that it was originally. So there is a command called merge here, and this allows us to change the values of entities that we already have loaded. And that includes things like scale, their position, and rotation and everything. And we can set how long it takes to go from one translation to another with this interpolation timing right here. So this 100 you can change, and then change how long it takes to go through animations. And to get this to be back in the same place that it was, we can't just scale it up because we also have to move everything. And so I have everything loaded in at this block, and we need to move it over to the original origin that we had. I need to move it over to this position. So I need to figure out the distance here, and that's going to go in this translate spot. Okay, so over here I have -8 and 1 to get it back to that origin spot. I've reset the scale to 1 here. I'm going to have to resummon this house because I forgot something. We need to give each block its own name with a tag. Right now I'm just calling everything house, but we can also give it a tag that has a specific name, and I'm just going to use the name of its position. So we're going to drag this all the way down and then resave that function. All right, I redid that, and then there's our house again. All right, so now we can scale this to 1, and then we need to shift this -8 and 1 blocks, and then we're going to make this merge command here. So we're going to drag it all the way down, copy that into its own function file. All right, reload. All right, now we should be able to run this, and it should animate. It does. It does indeed animate, just the wrong direction. Okay, so I have the translation numbers done incorrectly. Okay, yeah, I have it as a negative instead of a plus. All right, reload, rerun that function, and then the whole house moves over to where it should be. Perfect. All right, so let's combine both of those things. So we can do data merge and the timing, and so like block by block will scale itself. Let's reset, and I'll make the small house. And what I think I want to do is, let's see, from the top down, I want the top to go up to scale, and then like slice by slice, like go over and go to scale. So let's work on that. So what I need to do, actually I need to add another column here. Let me do that. Okay, I've actually split this out into merge, so I have timing and no timing. And now I need to do how I actually want the animation. So I want the top to be first. So I need the max of 28. So I need to do like 28 minus the elevation, and that will just basically do the inverse. And then copy all of this stuff down, paste that, and then now we need the scoreboard stuff down at the bottom. So I'm gonna copy these lines and add them to the bottom of our function here. And I need to rename this to be house entity merge, and 30 should be fine. Save it, and all right, so I'm gonna reload and then merge. That looks a little bit weird. It looks cool. I think I want to slow it down a little bit. Let's reload it. I want to look at it from the side too. Okay, so I just want to let's try every 3 ticks. I'm gonna look at it from an angle over here. Merge. Yeah, it looks pretty cool. Wasn't what I was expecting it to look like, but I know it makes sense. It's neat. Okay, I added this here. So now entity summon has translation and no translation. And we're going to do summon entities with no translation and no timing. All right, so here we can reload the house. And now if I turn hitboxes on, you can see that every single entity is actually loaded in their actual X, Y, and Z position. Well, that's great. So what can we actually do with that now? Well, there are times when you want to do things relative to each block or relative to the whole structure. Let's look at doing the same thing in two different cases. I have two different quarter scale houses loaded in. And this one has all of the blocks translated from a single location right here. And this one, all of the blocks are located in their actual positions. And so there is no translation. They all have their own individual positions. So now I'm going to try to rotate all of these entities. So I'm going to execute as the house tag and then run data merge and then apply a rotation. I'm going to do -20. And this is going to have every single entity rotate by 20 degrees. And so as you can see, the house on the left actually all stays together in one place. And the house on the right, each individual block is what is rotating in its own place. And so if you did something weirder, let's try, no, I don't want to go into the ground. Let's do -30. -30, and I'll turn off hitboxes. It's a weird effect. Like, this is useful for some cases. I haven't really found a use case for rotation like this. It's a weird effect, but let's go over when this is actually useful versus this. So let's do some applications with no translation and why it's useful. Let's try something where we set scale to 0 and then we do timing from the top down. All right, let's see what this looks like. I like that. That's cool. I haven't done something like that. I think it needs to be a little bit faster though. Let me move it back the other direction. So all I gotta do is change the scale and then just paste it in here, and then I'll save this to a new file. And I should be able to reload. And in go. Wait, what? Why? Oh. Wait. No, wait. Sorry, let me figure this out. Okay, I got it figured out. User error, as always. I didn't change this, so it was running down to the bottom, and then it was basically reloading the previous one that we had. So I just need to add that 2 there, save that, and then reload. And this is something I can show off, I guess. If you tell a function to like rerun, it will, and the block is already in the state that it needs to be in at the end of that function, it will replay the previous animation. It's a weird, I don't know if you call it a glitch or feature or what, but it's bizarre. Okay, I've reworked it just a bit. So now if we can get rid of it and it all kind of deletes itself going down. And then I did it also to rebuild going up. And I really like the effect of that. That looks really cool. That's what I was going for earlier. And just had to work on timing and like what is, like how often the function loops or how quickly the function loops and how quickly the block interpolates through that. Okay, so next up, I kind of want to put everything together and kind of do a multi-step animation. That'll probably be the last thing I'll do in this video. Much later, and I have something that kind of combines a lot of things we've done in the video into one animation. First off, we have a real house here, real blocks, and I'm going to run a function that will eat away the house and take it over and scale it into this little crystal, and then the crystal will spit it out over to this new location, and the building will be rotated. And then this building over here, also real blocks. So I can, I'm going to reset it, and then I'll actually tell you what's actually happening. I'm going to slow this down, but it might break the animation because we'll see. Okay, this is a normal house with blocks. What it's doing is it's deleting each block and replacing it with a display entity. And then it's telling that display entity to teleport over here as well as scale it. And then they're all going over here and being deleted. And then new ones were already here. and they're being told the opposite, to start teleporting, scaling, and then once they arrive in their destination over here, then they are deleted and replaced by a real block. Oh yeah, one more thing. I added another section to the spreadsheet. So how I delete this is I know where all the blocks are at, and so I'm just filling them with air. And so I have a timing and no timing section where it just sets a block in the right position. And also while I was doing that last animation, I added more sections here besides this setting the air. I also added some more things to teleport, and I added a section for killing entities with timing and no timing. I'll be leaving links to all the tools that I talked about in the description. I hope this helps some people out. I know that it actually helped me because it forced me to smooth some things out in the Google Sheets document, and I added some other things that I know I'll be using in the future. If you find any errors or have suggestions, I'm all ears. If you have questions and you at least tried to figure things out before asking, I'll do what I can. You can ask a question here down in the comments or over on the Discord. Once again, big thank you to Gamma02 for the program. Without that, I'd probably still be doing things manually or stuck trying to figure out how to parse data out of an MBT file. I hope you have a nice day, and I'll see you next time. Bye-bye.